Hi everyone, welcome back to the last of our Module 7 notes. We're going to finish up talking about finding the roots or zeros of a polynomial, but this time not just if they're rational. So we're going to find all roots, even if they are imaginary, complex, or irrational. So what I'll do is just quickly remind us as a review what it looks like to find all of the zeros of a polynomial that has only rational zeros or roots. And then we're going to start looking at what it looks like when some of them are not rational. So first example, we've got a 4-term polynomial. I'm going to factor this with grouping. So I'm going to find the GCF of these two terms and the GCF of these. I may run out of room, so I'm going to start over on this side. So I've got f of x equals, so here it's going to be x squared. If I factor that out, I have an x plus 4 left. And then here, I'm going to factor out a negative 4, and then I have an x plus 4 left. Okay, so my parentheses are the same. It's the same term. That's what I want. So now I can combine the x squared and the minus 4 in one factor. And then I have that x plus 4. All right, and then here, this is a difference of squares. So remember, we're not done factoring. This is x plus 2, x minus 2. And then I still have that x plus 4. So we're done here. This is completely factored. And from here, I can quickly see what my zeros are. It's just the values that are going to make these factors equal to 0. So if I set this equal to 0, then my zeros are, I'm going to say zeros or roots. For our purposes, those are going to mean the same thing. So those values are going to be negative 2, positive 2, and negative 4. Don't forget that the number of zeros is equal to the highest degree of the polynomial. So I have 3 zeros here, and this was an x to the 3rd power. So that makes sense. Sometimes we're going to find maybe like 2 rational roots, and then if you don't have the 3rd one, it means that one's probably complex or irrational. But we have all 3 here, so they're all accounted for. This is what we've been used to working on. Now we're going to see an example of when the roots are not rational. So for this one, to factor, this is a difference of squares. So I'm going to use my pattern where this is going to factor as x squared minus 2 and x squared plus 2. Now, both of these are situations where we cannot factor using the methods we've learned so far. This is a difference of 2 numbers, but they are not perfect squares. 2 is not a perfect square. And then this is just a sum of 2 numbers. The only sum of numbers or values that we can factor are sum of cubes. That's not the situation. So I'm going to show you 2 ways that you can find what the zeros are when we're in a situation like this. Now, one of the ways will always work. The other only works when it's x squared. So let's do that way first. That's kind of our harder way. So I'm going to find the zeros of, let's do this one first. We are going to, let's see which one I did for this one. We're going to set this one equal to 0. So I'm going to say x squared minus 2 equals 0. Because remember, I want the value that makes this whole parentheses 0. So I'm going to set it equal to 0. Well, that's really simple. I'm just going to add 2 to both sides of the equation. And then I'm going to take the square root of both sides. Now, careful here. When we take the square root of both sides of the equation, our answer is going to be the positive and negative square root of 2. Okay, because remember, you can multiply a negative by itself and it'll still give you a positive. So this is plus or minus square root 2. That's an irrational number. If we were to write this as a decimal, it would not end. And so that is not a rational root, but it's still a root. So we've got 2 so far. Now we're going to set this one equal to 0 and find out what values will make this equal to 0. So I'm going to write this one over here. And for this method, I'm going to show you the other way. When I have an x squared, so when it's a quadratic, I can use the quadratic formula. So we're going to set it equal to 0. I'm going to remind myself what the a, b, and c values are. So a is this coefficient, that's 1. B would be the coefficient in front of x to the first. We don't have it, so it's 0. And then C is the constant. So let's remind ourselves the quadratic formula is the opposite of lowercase b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to simplify this now. So this is just 0, so I'm going to have plus or minus the square root of, this is just 0, so it's negative 4 times 2, it's negative 8. If I want to take the square root of something, I need to separate it into factors where 1 you can take the square root of. So what I mean is I'm going to do the square root of negative 2 times 4. I can take the square root of 4. So that's plus or minus 2. And then what's left over is negative 2. And we don't want a negative under the square root. So I'm going to do one more step. This is plus or minus 2 square root negative 1 times 2. And the square root of negative 1 is I, our imaginary number. So this is plus or minus 2i square root 2 over 2. These 2's that are outside of the square root, there's one in the numerator, one in the denominator. These are all being multiplied, so I get to cancel those. And so I know I'm running out of room, but my final zeros are going to be I root 2, the positive and negative. So kind of a lot of steps there. The quadratic definitely takes longer. I would suggest using the quadratic formula only if you have a b value. If you don't, if it's just x squared plus or minus a number, definitely do this method. We could have done that for this one. I just wanted to show you both ways. Okay. So finally, we have all of our zeros. We have plus or minus I root 2, that's 2 zeros, and we have plus or minus square root 2, that's our other 2. So we have 4 total, and our original polynomial was x to the 4th. Okay, so 2 zeros here and 2 zeros here. You may notice once you start finding these complex zeros that they always come in what's called a conjugate pair. It means an opposite pair. So if I were to be given that one of the zeros was positive square root 2, then I would automatically know that the other 0 is negative square root 2. They always, always, always come in conjugate pairs or opposite pairs. So let's try that out, what that means for these polynomials. It says, if a polynomial has the zeros negative 1, 3, and 3i, we also know that the opposite of this is a 0, negative 3i. So 3i and negative 3i come in a pair, always, always, always. Let's try another one. If a polynomial has the zeros 2 and 3 minus root 5, then we also know the conjugate of this, 3 plus root 5, is also a 0. So remember, if it's rational, it just is alone. If it's a complex root, we know automatically that the conjugate is also a 0. So that's a really typical type of problem. You'll be given some of the zeros, and you have to find the rest of them. All right. And then one last type of problem you may see is if you're given some zeros, to write the polynomial with said zeros. So quickly what I want to do is write in any that are missing first, and then we will write the polynomial. So I have 3 and negative 7i. Well, using what we know about conjugate pairs, I know 7i also has to be a 0, so negative and positive. So if I want to write this as a polynomial, what I'm going to do is write factors where these make them 0. So my first factor would be x minus 3. My second factor would be x plus 7i. And the last one would be x minus 7i. Now we can absolutely multiply these out. You may see that in your homework where it needs to be multiplied out. If we did, we would have x to the 3rd as our highest power and then a bunch of terms after that. But for now, I'm just going to leave it like this. Okay, and then in my other color, let's do this one. So first, again, I want to list if there's any other that I'm missing. Ooh, I see an irrational root right here. It's negative, so I know also the positive is a factor. So let's write this polynomial. I'm just going to go through and write the factors that would be 0 or equal to 0 if these were the x value. So I've got x minus 4, x plus root 2, and then I'll do the opposite, x minus root 2, x plus 3, and x minus 1. So really, really important that you can either look at factored forms of polynomials and state what the zeros are, or go the opposite direction. Look at the zeros and state what the factors are. So really important to go both directions. Thanks so much for watching, guys, and good luck on practicing this skill.